Hey, welcome back to part 2 of solving logarithmic equations. If you didn't see the first part, I recommend go checking that out first, where we talk about case 1. This video is going to be about case 2 for solving logarithmic equations. Let's get to it. Okay, again, video disclaimer. If you do not know your rules for logs in terms of expanding and contracting them to simplify them, I recommend you review those notes or let me know and I can make a whole video about it. But for this one, we're going to need the fact that log of any base of a times b equals that log of x of a plus log base x of b. Okay, so this rule right here is going to be important in terms of expanding or contracting. For solving, we're always contracting. We're always making things smaller to make things simpler. So case number 2 is logs on both sides of the equation. Okay, so if we have, so here's the sort of rule or that we're going to follow. So if we have log of x equal to log of y, and let's give them the same base, let's say base 2. I seem to like base 2. I seem to be using it for all my examples. I don't know why. It could be anything, okay? So if I have log base 2 of x equal to log base 2 of y, it stands to reason that the only way these will ever be equal to each other is if x is equal to y. The insides have to be equal. So this is our goal. If we have logs on both sides of our equation, our equal sign, then we want to get them simplified enough down to where we have one log equal to another log, same base, then we can equal the insides and then just solve this equation. This becomes our new form that we're going to solve. So if you noticed from case number 1 in the first part of this video series is with logs, we're always converting it to some other form, some other equation, exponential, which then becomes quadratic or something along those lines. So when it comes to solving logs, we always want to get away from them. We want to get out of logarithmic form unless it's something we could just punch in our calculator, then okay, then we're done. Nothing to solve there. So let me give you an example. If we had log base 2 of x plus log base 2 of x plus 2 equals log base 2 of x plus 6. Okay. Like I said, for some reason, I like base 2. I keep choosing it. But again, it could be any base as long as they're the same. Okay, so we look at this equation. Obvious, we have logs on both sides of the equal sign. So my goal is to get it down to 1 log equal to 1 log. So the first thing we need to do is we need to simplify the left side of this equation where we have 2 logs. So plus sign, so we're going to be using this rule here when we have 2 logs adding, that becomes 1 log with the insides multiplying. So we're going to rewrite this as log base 2 of x times x plus 2. Okay, so then x and x plus 2 are multiplying now. Log equals log of 2 of x plus 6. Okay, we'll take it one step and we'll just simplify. So we're going to multiply this x in, x squared plus 2x. You don't have to do that right away, but it looks nice. Now we have this form. We have our case number 2. We have a log equal to a log. The bases are the same, 2 and 2. So the only thing that makes sense is that x squared plus 2x must equal x plus 6. The insides must be the same. So now again, we've transferred out of logarithmic form, so we need to re-evaluate, re-identify what kind of equation we have. So I see we have an x squared, so that means we have to set it equal to 0 because we have a quadratic. Again, if you haven't seen my video on solving quadratic equations, I recommend go check that out. It also has a PDF with steps to solve those equations. So we're going to subtract x and subtract 6 from both sides. X squared plus x minus 6 equals 0. We're going to factor by double bubble. So we get x, what multiplies to -6 and adds to 1 is +3 and -2. T-chart, x equals -3 and x equals +2. Again, from the first part or the first video, I talked about once we solve, we have to take a look at our answers to make sure none of them give us a negative inside any one of these three logs from our original equation. So obviously, if I plug in -3, I get a negative here. I get a negative here. I don't get a negative here, but it doesn't matter because I have a negative in at least one of the logs, and that makes that part undefined, which makes the whole equation undefined at this value of x, so we reject it. And our answer is only going to be x equals +2. So again, just to restate, it doesn't matter that the x itself is negative. It matters that when I plug it into the log, then it's negative, okay? It could be negative x and still be positive up there, like with the log base 2 of x plus 6, right? It was positive there, so it would have been fine there, but it just didn't work in the others, okay? So just to go one step further, instead of doing a whole nother video, I'm just going to talk about real quickly a different example that involves both case 1 and case 2, where we have to think just a little bit more, okay? So if we had log base 2 of x, again, base 2, don't know why, log base 2 of x squared plus 5. If we have something like this, first glance, we have logs on both sides, so this must be case 2. However, I cannot get this equation to ever look exactly like case 1, where we have 1 log equal to 1 log. This +5 is in the way, right? So I can't solve this using case 2 because I can never get it to become 1 log equal to 1 log. So my only option is to actually think about this as case 1, 1 log equal to a number. So what we're going to do here is we're going to get this number alone and get the logs to one side. So we're going to actually subtract this log base 2 of x squared from both sides. Okay, so what this would look like is log base 2 of x minus log base 2 of x squared equals +5. Now we have logs on one side, number on the other. This is case 1, so what do I have to do? I have to simplify the left side here, and I have to then convert to exponential form. So I'll just do it very fast, okay? Minus means division, so it's similar to the rule I put up top here, okay? The log, when they're adding, it becomes multiplication, but when we're subtracting, it becomes division. So we have x divided by x squared, which is just 1 over x, okay? I'm just running out of space, so making a little bit, doing some of the, not showing all of the steps here, but x divided by x squared becomes 1 over x in here. Now we are at case 1, so we convert this to exponential form, and that looks like what? 2 is our base. Exponent is 5, equal to 1 over x. Then we would solve this, okay? So I trust you know how to solve that. We're going to simplify by doing 2 to the 5th is 32. Okay, and then from there we have a proportion we can cross multiply and get x alone from there. Okay, I'm going to leave that up to you. The answer is x equals 1 over 32, in case you want to check yourself. Okay, so I hope this was illuminating. Case 1 was the first video, and case 2, this one, to show you how to solve logarithmic equations. They're all either case 1 or case 2. Okay, and no matter what, as long as you follow these, you're going to get there, okay? So now that we're done with the case 1, case 2, I'll explain this backdrop, okay? This is actually a picture I took in Barcelona, Spain. I just finished right now, finished reading Dan Brown's new book, Origins, one of those, and the majority of the book takes place in Spain and Barcelona, so it was giving me some nostalgic moments, so I figured I would take or show you this picture, which is from my favorite part, or my favorite place in Barcelona, which was this little park that you had to take a gondola across this bay to the top of this park, and you were overlooking the whole city. It was really a beautiful spot. So if you're ever in Barcelona, take that gondola ride to this park. It's really magnificent. All right, until next time, if you have any questions, please put them in the comment section. Definitely, if you enjoyed this, subscribe, hit the like button, turn on your notifications, share it with your friends, do all that good stuff. Helps me out and helps your friends out too, okay? And I will see you guys next time. If you're looking for also some more one-on-one help, please visit my website or follow the link in the description to book a one-on-one session with me anytime. All right, I'll see you guys soon.